For every 3 televisions sold around the world, 1 proudly bears the mark, "Made in China." This is a country that has transformed its enormous population into a precision-driven workforce, powering massive assembly lines that hum day and night. Behind these towering steel walls lies a secret universe, where sheets of glass thinner than a strand of hair, LEDs tinier than grains of rice, and millions of microscopic circuits are pieced together with surgical accuracy. All these elements merge to create sleek, powerful machines that bring entertainment to life. Today, we step inside one of China's largest TV factories to explore how this nation has climbed to the top of the global tech stage. China's dominance isn't just the result of vast assembly lines or lightning-fast production speeds. It's also the product of a strategy that leveraged affordable labor to its fullest. For decades, engineers and manufacturers have studied Western technology, adapted it, improved upon it, and then launched it into mass production, delivering quality at a fraction of the price. This strategy has paid off. In a world where over 231 million color TVs are sold each year, 1 in 3 comes from China, fast, affordable, yet reliable enough to reach millions of households. Meanwhile, in the United States, electronics giants pour billions into research and innovation, crafting premium brands. American TVs are often pricier, focusing on durability, design, and a distinct user experience rather than sheer numbers. 2 different paths, each with its own philosophy. Yet it's this very contrast that has sculpted the modern electronics landscape. The question now is, which approach will define the future of the industry? From the humble black and white TVs of the mid-20th century to the introduction of color screens in the 1960s, television quickly evolved into a vibrant centerpiece of daily life. By the 1990s, the rise of flat panels redefined living rooms, turning TVs into the focal point of home entertainment. In the early 2000s, LED televisions made their debut, sleeker, more energy efficient, and sharper than anything before. But the true revolution arrived with smart TVs suddenly. That slim rectangle was no longer just for watching shows, it became a portal to the internet, a launcher for apps, and the central hub of family entertainment. Fast forward to today, and with ultra-high resolutions like 4K and even 8K, combined with impossibly thin designs, televisions have become a common fixture in millions of homes around the globe. In China, a TV's journey doesn't start with glass or metal, it starts with data. Tech companies invest heavily in market research, meticulously gathering and analyzing every trend, preference, and behavior of potential consumers. They know that sprawling American living rooms often demand giant screens for a cinematic experience. Meanwhile, in Asia's dense urban landscapes, compact apartments drive a preference for smaller, feature-packed designs. These insights influence every production choice, from the size of the screen, 4K or 8K resolution, and voice control features, to seamless integration with smart home systems. Millions of data points, from online surveys and customer reviews to retail trends, form the blueprint for engineers. Once the research is complete, engineers draft detailed plans, construct 3D models, and set the stage for manufacturing, where these concepts will come alive on enormous industrial production lines. And it all begins with the most critical part of the TV, the screen. Inside enormous, spotless clean rooms, every speck of dust and drop of humidity is strictly controlled, because even a single particle could destroy a panel worth hundreds of dollars. 2 ultra-thin sheets of glass, polished until they are perfectly flat, glide onto the assembly line and are pressed together like a delicate sandwich. Between them lies the liquid crystal layer, the heart of the screen, responsible for making each pixel light up and shift color with electrical signals. On the first sheet, millions of microscopic transistors are meticulously arranged, forming what looks like a tiny cityscape. Each transistor acts as a miniature switch, controlling the flow of light with pinpoint precision. On the second sheet, engineers apply red, green, and blue color filters. These 3 primary colors, combined at varying intensities, create millions of unique shades, giving images their lifelike vibrancy and natural detail. To guide light with absolute accuracy, polarizing films are attached to both the front and back of the panel, channeling every beam in exactly the right direction. When all the layers are fused together perfectly, a lightweight LCD panel is born, containing millions of synchronized pixels ready to bring the visual world to life. But the LCD panel alone cannot shine. Those millions of pixels would remain dark without a hidden partner, the LED backlight. This invisible system, positioned directly behind the glass, transforms the silent panel into a glowing canvas of rich, vivid images. Even on these sprawling assembly lines, human hands are essential. Skilled workers carefully attach strips of LEDs along the edges of the frame, each one placed precisely to ensure light spreads evenly across every corner of the screen. These LEDs are tiny, no larger than grains of rice, yet powerful enough to illuminate the entire display. Each LED is soldered onto an aluminum sheet that doubles as a heat sink, keeping the lights cool during hours of continuous operation. Even after the LEDs are mounted, the light they emit is far too harsh and uneven. To tame it, the glow passes through a sheet of transparent plexiglass, diffusing and scattering the beams to eliminate harsh spots and shadows. But the process doesn't stop there. Multiple layers of optical films are carefully stacked on top, fine-tuning brightness and balancing colors so that the final light appears perfectly uniform and natural. When this backlight finally merges with the LCD panel, the transformation is complete. What was once a lifeless sandwich of glass and liquid crystal now comes alive, ready to display vivid, moving images. At this stage, the TV's visual heart is fully prepared, a window ready to open onto entire worlds. But even with a glowing screen, the television is still silent. It can shine, but it cannot yet produce sound or orchestrate the flow of images. To awaken it fully, the electronic circuit boards, the brain and nerve center of the device, must be meticulously assembled. Here, billions of signals will be processed, translating electricity into both light and sound to create a complete sensory experience. On the assembly line, technicians stand in long rows, each performing precise, specialized tasks. With steady, nimble hands, they place tiny components onto bare circuit boards, transistors, capacitors, resistors, processors, and countless connectors. Each piece is like a microscopic puzzle tile, forming a complex network that governs how images appear, how sound travels, and how instantly the TV responds when a button on the remote is pressed. Once all components are in place, the boards pass through a bath of molten solder. Bright, flawless joints emerge, strong enough to ensure stable power flow without risk of short circuits or failures. Yet, human vigilance remains essential. Workers peer through magnifying lenses, inspecting every pathway to catch even the smallest flaw, because a single defective connection could halt the entire system. Once the circuit board passes inspection, it is carefully fastened to the TV frame with tiny screws and then seamlessly connected to the LCD screen and LED backlight. Flat, ribbon-like cables link every component into a smooth, integrated network. On the main board, HDMI, USB, and LAN ports are installed, gateways that allow the TV to communicate with the outside world. Finally, all the pieces, the screen, backlight, and circuitry, come together. What was once a lifeless assembly of glass and plastic has now become a smart machine, ready to project vivid images, deliver immersive sound, and connect to the internet. Silence transforms into a hub of home entertainment. Yet, even at this stage, the television isn't fully complete. It still requires one last layer of protection, a sturdy armor to shield its delicate inner workings from shocks, dust, and the rigors of transport. This step occurs in the high-pressure molding area, where plastic components are shaped with incredible precision. The front cover, side bezels, and back panel are engineered to be strong enough to safeguard sensitive electronics, yet light enough for workers to handle easily. As the parts arrive at the final assembly stage, precision becomes paramount. Every piece is meticulously positioned and adjusted down to the smallest fraction, locking perfectly with the circuits and fragile display. Screws, clips, and thermal welds secure every connection, merging the separate elements into a single, robust unit. Even a misalignment of just a few millimeters could create uneven pressure on the screen, causing it to warp, or worse, crack. That's why every motion here is deliberate, calculated, and exact. As the outer shell finally closes around the core, the transformation reaches its pinnacle, What began as a fragile collection of glass, circuits, and wires now resides in a sturdy, polished body built to endure daily use. The TV no longer looks like a work in progress, it appears complete, refined, and ready. Every detail has been secured with care, ensuring both durability and stability, and promising a vivid, uninterrupted viewing experience for years to come. The protective frame not only completes the look, it guarantees the technology inside can perform at its very best. Even when the TV looks complete, its journey isn't over. Before it can earn certification and leave the factory, it must pass a rigorous series of quality tests. The process begins with image inspection, the factor that defines the user's visual experience. Ultra-high-resolution cameras and sensitive optical sensors scan every inch of the screen, hunting for the tiniest dead pixels, those that remain permanently dark or lit, disrupting the uniformity of the display. The system also measures brightness across the panel, detecting areas that are too bright, too dim, or plagued by light bleed. Next comes color testing. Using gradient scales, standardized color charts, and rapid video sequences, engineers assess tone reproduction, color accuracy, and smoothness of transitions. Every shade, from the most vivid red to the deepest blue, is examined, because even the smallest deviation can compromise the viewing experience. Audio testing follows. Speakers and signal paths are pushed through a broad spectrum of frequencies, from deep, resonant bass to sharp, crisp treble, and run for extended periods to ensure the sound remains clear, free from distortion or buzzing. Specialized microphones capture every note, comparing it against technical standards to guarantee that every channel delivers perfectly, from soft background melodies to explosive action sequences. Meanwhile, the entire electronic circuitry undergoes meticulous scrutiny. Engineers employ industrial magnifiers and advanced measurement tools to inspect solder joints, signal pathways, and component performance, eliminating any risk of short circuits, broken lines, or components operating beyond their limits. Every detail, no matter how small, must meet the highest standards of precision. Only then can the television move forward, ready to transform from a lifeless assembly into a fully functioning hub of entertainment. Finally, the endurance tests begin. Each TV is powered on and off thousands of times, placed inside chambers that simulate extreme temperatures and humidity, and even subjected to intense vibrations to mimic the stresses of shipping. Only after surviving this gauntlet of challenges does the television earn its certification seal, officially proving it's ready to leave the factory and enter the market. But even after passing every inspection, the TV is still just a shell, a lifeless piece of hardware. To become a truly smart device, it needs one final transformation: software installation. Workers connect each unit to specialized computers that install the operating system along with essential applications. This digital brain gives the TV the ability not only to display images and produce sound but also to connect to the internet, launch platforms like YouTube or Netflix, and integrate seamlessly with other devices in the home ecosystem. Engineers then run a series of functional tests. They measure how quickly the remote responds, check the stability of the Wi-Fi connection, and verify the TV's ability to run multiple apps smoothly. The interface is inspected for speed, clarity, and ease of use, ensuring it feels intuitive for anyone operating it. Only when every function works flawlessly, from connectivity to navigation, can the television officially earn the title of Smart TV, a complete entertainment hub ready for families around the world. With assembly and inspections complete, the TV enters the final stage of its journey. Workers carefully place each unit into mold foam frames, securing every corner to minimize vibrations during transport and protect the fragile technology inside. The TV's body is then carefully wrapped in anti-static bags and protective plastic film, ensuring the surface stays free from scratches and shielded from environmental damage. Next, each unit is packed into sturdy, multi-layered cartons, clearly marked with batch numbers, QR codes, and production dates, allowing precise tracking through the entire supply chain. Accessories like the remote control, power cord, and user manual are neatly arranged inside, making certain every package arrives complete. These cartons are stacked onto pallets, wrapped tightly in stretch film, and transported to central warehouses. From there, thousands of containers are loaded and shipped, by road, sea, and air to homes across the globe. By the time a TV finally lands in a living room, it is far more than just an electronic device. It is the culmination of a vast industrial engine where hundreds of people, sophisticated machines, and tightly coordinated processes come together to achieve near-perfect precision in every unit. Behind that seemingly fragile shell lies a complex technological heartbeat, from clean rooms assembling ultra-thin screens, to workers meticulously placing tiny LEDs, to intricate circuit boards and intelligent software. China has leveraged its labor force at scale, transforming it into a massive production engine that delivers hundreds of millions of TVs worldwide. But the question remains, will sheer speed and scale be enough to maintain this dominance, or will innovation and premium branding from other nations reshape the future of the industry? Share your thoughts in the comments below. And if you want to discover more behind-the-scenes stories of the machines and technology we use every day, don't forget to like, subscribe, and hit the bell so you won't miss the next journey into the hidden world of innovation.